Hey everybody, so today we are talking about mutually exclusive events versus independent events. Mutually exclusive events are events that cannot occur at the same time, so when event A occurs, event B cannot also occur. This is often confused with independent events by thinking that since the events are separated, they are independent from each other. This is not true, and these concepts are completely different. Independent events can occur at the same time, but the probability of one event occurring does not affect the probability of the other event occurring. So here are a few examples of independent events. As you can see, for each example, both events can occur at the same time, but the probability of one event occurring does not affect the probability of the other event occurring. So the example that we're going to be looking at is landing on heads after flipping a coin and rolling a 5 on a single 6-sided die. Before we look at the example, we can see that the probability of event A occurring, given that event B occurs, is the same as the probability of just event A occurring if both events are independent, and vice versa. And we can also see that the probability of event A and B occurring is the same as the probability of event A times the probability of event B. So if we look at the first example, we can say that event A is landing on heads and event B is rolling a 5 on a 6-sided die. And for independent events, the probability of A occurring, given that B occurs, is the same as the probability of just A occurring. And the way we can find the probability of A given B is by doing the probability of A and B over the probability of B. So if we do that, we can find that this should equal just the probability of A because these events are independent. So the probability of A is 1/2 because you're flipping a coin, and the probability of B is 1/6 because you are rolling a dice. And if we do that and we put that over 1/6, we would get 1/12 over 1/6, and then if you multiply by the reciprocal, we will get 6 over 12, which is equal to 1/2, which is the same of just flipping a coin and landing on heads. An example of two mutually exclusive events would be rolling a 3 on a die and rolling a 4 on a die. These events cannot possibly occur at the same time, so they would be mutually exclusive from each other. For mutually exclusive events, the probability of A or B is equal to the probability of A plus the probability of B, and we can see how this is true by looking at the previous example. To show how the addition rule for mutually exclusive events works, we can make a new event called C, and this would be rolling a 1, 2, 5, or 6 on the die, and we already know that this probability would be 2/3 since it can be any of these 4 numbers out of the 6 total numbers on the die, and 4 over 6 simplifies to 2/3. And we can also find the probability of C by doing the probability of A or B and subtracting that from 1. So the probability of A is 1 over 6 because it's only one number, and then you add this with the probability of B, which is also 1/6, and then you would take that and subtract it from 1. The probability, so 1 over 6 plus 1 over 6 simplifies to 2 over 6, which simplifies to 1/3. And then if you take 1 and you do 1 minus 1/3, you will get 2/3, which is the same as 4 over 6, which is the same as the probability of C. So that shows you how the probability of A or B equals the probability of A plus the probability of B for mutually exclusive events. An easy trick to remember the difference between mutually exclusive events and independent events is by thinking if it is possible for both events to occur at the same time. So if they cannot occur at the same time, then they would be mutually exclusive events. but if they can occur at the same time, then they may be independent if the probability of one does not affect the probability of the other. Thanks for watching.